Greetings, I'm Michele Barbato, a professor of structural engineering and structural mechanics at the University of California, Davis, and I'm humbled and honored to receive the Icons of Change Award for the Sustainable Development Goal 11 for Sustainable Cities and Communities. Um, as a recognition of the work that my research group has been doing in this area. And I'm honored to have this opportunity to give a short keynote presentation on our work that also addresses other sustainable development goals of the United Nations, including the Sustainable Development Goal 8 of decent work and economic growth, the number 9 for industry, innovation, and sustainable infrastructure, and the Sustainable Development Goal 13 for climate action. Um, I will describe first the motivation of our research. And here I'll focus mostly on the work that we are doing in the US, although the research that we are performing can really be applied across different regions and different places. And so the first issue that we are encountering is the issue of aging infrastructure. Infrastructures, both the physical infrastructure and our cyber infrastructure is aging, is in need of repair, is in need of improvement to follow and support the improvement of living or life quality across the US and the world. In addition to that, we are also suffering an housing crisis. There is a severe supply shortage of housing in the United States and actually in the world. It is expected that in the next 50 to 80 years, we will need 2 billion new homes in order to address the increase in population and the improvement of quality of living in the world. So we need to find a way of producing affordable and sustainable housing for everybody. At the same time, we have the big challenge of climate change with the issues in terms of mitigating the emissions, producing homes, infrastructure that are more sustainable, but also that can adapt to the changes and improve in resilience. And we need to do that with an eye to equity and climate justice so that everybody can benefit from the development and the improvement that are needed to address the problem of climate change. At the same time, we have a big opportunity thanks to the new technologies that have been developed, such as additive manufacturing and 3D printing, high-performance computing, virtual reality, and artificial intelligence and machine learning. So these are tools that are becoming available and that can help us in addressing the issues that we have identified before. So how is the research of my research group addressing this problem, and where are we providing our contribution? On one side, we are developing nature-based solutions. We are developing new engineering knowledge for earth and construction that is characterized by low embodied energy, low operational energy, so highly sustainable materials that are also very resistant to natural hazards, including hurricanes, fires, tornadoes. Here you can see a fire test on our earth block and a windborne debris impact test of our earth blocks construction. We are also developing modular construction technologies, for example, interlocking mortarless earth blocks and prefabricated or integrated panels that can be used so that we reduce the waste of materials during construction and we make the construction more efficient and sustainable. And we can also reduce construction time with our technology of interlocking mortarless blocks up to 50%. We are also working on 3D printing. On one side, the more classical 3D printing of cementitious materials, but we are also working on 3D printing on soil-based materials, again, in order to achieve at the same time sustainability, affordability, and safety. And then we are working on other types of sustainable materials, on binders and concrete that are substituting clinker with, for example, for gypsum, with agro-based materials, with mycelium research that is using fundamentally mushrooms to build materials that can be used for construction of buildings and also to substitute blades of wind turbines. And then we are working on high performance materials, on engineered cementitious material and engineered geopolymer composites that produce fundamentally a bendable concrete that can deform much more than normal concrete and reduce damage or self-repair, as well as high performance and ultra high performance concrete. We also are developing advanced numerical modeling for masonry, for reinforced concrete structures, for reinforced concrete structure retrofitted using FRP. And here you can see one of our models and the capabilities of reproducing the mechanical behavior of masonry walls. We are also developing new performance-based design approaches for hurricanes, for winds, for multi-hazard problems, and for accounting for the effect of climate change and structural aging. And then we are working on wildfire risk mitigation, which is a huge problem, not only here in California, but really everywhere in the world, with all of the different facets of air pollution, structural risk, and the development of highly technological solutions for sensing early fire detection and in order to save communities, populations, and individuals from the risk associated with wildfires. With all of that, we also have a vision for the future. We are trying to develop what we call the house of the future, that is using earthen construction, geopolymer buildings, materials that are reducing the emissions, that are improving the sustainability, reducing the cost, making the house available to everybody, but also that are connecting with the novel technologies that are now available. For example, with the Internet of Things, integrating buildings that can also provide service to the occupants and connected with the communities in order to provide additional safety. And then we are also working toward the community of the future, something that uses distributed renewable energy in order to both reduce the requirements in terms of pollution, but also increase the resilience of communities under critical events like wildfires. And we are developing methodologies for climate-driven risk mitigation at the community level. We are also looking at technologies that are going to be beyond our planet, development of Mars blocks for construction on Mars, for supporting extraplanetary exploration and extraplanetary colonization. And we are also developing facilities for testing of our materials under severe wildfire conditions. And so with all of these, I'd like to conclude by thanking again the award committee for the Icons of Change award and recognize the importance of all the collaborators that across the years have supported and helped this research, including my mentors, Dr. Conte, Dr. Ciampoli, Dr. Spacone, Dr. Monti, my mentees, a long list of very talented individuals that are doing great work after working with me, and then the multiple teams that I've been blessed to work with over the years, as well as the funding agencies, because all of this research without support, funding, and trust is impossible. And with this, I'd like to thank you very much. And here are my contact information if anybody wants additional information. Thank you.